Hello friends, welcome to our science talk. I am Aparajita and today we are going to learn all about quantum. So quantum is a word that is being widely used in popular culture these days.
Quantum carburetor?
That's quantum leap! I'm talking about quantum physics!
But you know, what does it mean actually? The word itself means the smallest unit of energy or mass or any physical quantity. Quantum physics deals with small objects like atoms, molecules or subatomic particles. And essentially in quantum physics or in quantum mechanics, however you want to call it, we deal with fundamental theories, fundamental interactions that can describe nature at the smallest energy and length scale. Well, what I have just said is just for its definition. As for reality, the quantum world is very different from the regular classical world we see around us. Just take for example, you could be in this room and outside at the same time. Crazy, isn't it? So things that happen at the quantum regime are very unintuitive and very difficult to visualize with our classical concepts. But still they are very important and very interesting to understand because quantum mechanics is the key to describe all the phenomena, all the fundamental interactions we see around us.
Quantum physics makes me so happy.
Yeah, I'm glad.
It's like looking at the universe naked.
Let me just try and give you an example of how weird the quantum mechanics can be. There is something called quantum tunneling. What it says is a quantum scale object can pass through a physical barrier, an energy barrier for instance, without having any trouble, something that a classical object would never be able to make. Let's take this example. Let's say this ball at my hand. Let's just think that this is the electron for now, and I'm bouncing it against that wall. And it came back to me, second time, got it back again by chance, and the third time, oops, where did it go? Did it just go to the other side of the wall? Yes. In quantum mechanics, a particle has a finite probability to be on the other side of the barrier, and this happens irrespective of the barrier height with respect to the energy of the particle. And however weird this phenomena might be, thanks to this phenomena that we have the sunlight. You know, in the core of the sun, two protons tunnels into each other, and in this process it releases massive amount of energy, and that's the key of our sunlight. Without that sunlight, we wouldn't exist. All good. But are you already questioning what makes the particle go to the other side of the barrier? No? Then you should. Actually, this brings us to the next strange phenomena in quantum mechanics that's called wave-particle duality. In fact, back in the beginning of the 1900s, scientists couldn't explain the outcome of a few experiments only by taking the classical concepts of wave and particle. This is when people started questioning if waves and particles can interchange their characters sometimes, because that would perfectly explain the outcome of those experiments. This whole new concept is called wave-particle duality, and this is considered to be the biggest starting point of quantum mechanics. And an outcome of this whole new concept is that everything we see around us has a characteristic wave associated with it, and that's called matter wave. So you remember me throwing the ball against the wall? What I was throwing was a solid object, whereas its wave allowed it to pass through the barrier, to go to the other side of the barrier. However, this doesn't quite work the same way for a macroscopic classical object because the mass is heavier, and that's why the associated wave is far too small to have any visible effect. That's all friends for today. We are going to be posting many interesting videos on cool science topics in our future Science Talk episodes. So press that subscribe button, and if you want to learn more about what I just said today, go in the description box and check out the links. That's all. See you soon. Let's see if we can make it. No, we're too heavy.